I made some upgrades to my cluster. Now, one reason to run a bunch of capable machines together like this as a cluster is to be able to combine their memory. You can run larger models, like the 1 trillion parameter gmktec, for example, which runs on this, by the way. Each one of these framework desktop boards has the AMD Ryzen AI Max Plus 395, otherwise known as Strix Halo, with 128 gigabytes of memory that can be used for running LLMs. And together, these four have 512 gigabytes. Now, this might look familiar already because I already did a video explaining this whole cluster setup, and so did Jeff Geerling. But if you take a closer look, you might notice that I've added a few things. That took a bunch of time, experimentation, and money, and we saw improvements. Now, you might have heard of the DGX Spark and machines like that. And while running Llama CPP on that for chat is not the fastest thing in the world, but when you combine multiple Sparks together, and I have a separate members video for that, and I have other clustering videos coming up soon. Besides the 10 gigabit Ethernet RJ45 jack, they have these two QSFP ports for high-speed networking. And that, of course, allows better clustering capabilities so we can run larger models. This is something that the AMD-based Strix Halo machines don't really have until now. I've tested a bunch of these Strix Halo-based little mini PCs that have recently come out, and you can see videos about these on the channel. But for this upgrade, only the framework one would work. Framework being framework, they actually included an expansion point, a PCIe port, and that port allows us to add a faster network card. Now, why are we doing this with the network upgrades? For this, and that's because, as Jeff showed in his video, and I showed in mine, and Donato Capitella, check out his channel below, I'll link to it down below. He has a really nice video as well, going into a lot of detail. They both complained about the network bottleneck.
For small models that fit in the RAM on a single node here, like this 70 billion parameter Llama model, I got 37 tokens per second. When I put that on the cluster and distributed the model over 4 nodes, I got 15? Yeah, AI clustering isn't really about speed, at least if you don't have $1 million budgets.
Well, you don't really need $1 million budgets for this, because there's two ways you can take advantage of a cluster of computers like this. One way is to just run Llama CPP and improve your speed just by upgrading the network card. And the other way has to do with running a different software stack, VLLM instead of Llama CPP, and cleverly distributing your load. And that way you can get speeds like this. And as I mentioned in my previous videos, things are actually heading this way. Here's a recent post from Cursor, how they're trying to scale long-running autonomous coding. And in my opinion, that's the next step for software developers, being able to run multiple agents concurrently. Because running chat is extremely limiting. Running an agent is not as limiting, but still running a single agent is limiting. The first time I had to answer what happened on this PC, I knew some of the tools, but I didn't actually understand the artifacts. That's why I've been watching video courses on the 13 Cubed YouTube channel. This is 13 Cubed, premium practitioner-focused digital forensics training without the premium cost. They have a YouTube channel, and the free content is opposite of marketing fluff. We're talking deep technical breakdowns and real forensic analysis that you can watch right now. The paid courses go way beyond free videos. Hands-on investigations with realistic evidence, triage collections, disk images, and memory captures across Windows, Linux, and Mac OS. And the certifications are practical for the same reason. You don't just answer multiple choice questions, you're given realistic evidence like disk memory captures, you analyze the artifacts, build a timeline, and answer investigative questions the way you would on a real case. Right now I'm in the paid Mac OS course, and it's teaching me how to find artifacts, not just what the answer is. This one uses a day-by-day threat actor timeline so I can validate my work. And there's a built-in comments section where I can ask instructors questions directly, plus a community forum for students. And the value prop is honestly wild compared to the $10,000 you pay for similar courses elsewhere. Your access is 365 days, so you can renew later at a discount, and your cert is verifiable through a third-party service. So start with a free 13 Cubed YouTube channel, then check out the courses and the certs with the link below, and use code ALEX26 for $100 off any course or bundle. Get premium cybersecurity training without the premium cost. Link below. Getting back to the network upgrade, for months I've been going down a network rabbit hole. I've upgraded my network setup to 10 gigs throughout my whole office. Then my first attempt at upgrading the framework cluster was to grab these 25 gigabyte network cards, which are actually pretty cheap on eBay. There's a ton of them out there. This is the Chelseo T6225CR dual port. Anyway, it's 25 gigs, and there's 2 of them, thanks to a tip from a subscriber. Now, since the framework desktop board is limited to what size of of adapter you can plug into it. You can't plug a card like this. It's just physically too long. You need to plug it into a little riser or an adapter like this. And this size plugs into the framework board's 4x PCIe slot. Well, this was fine by itself, and I can connect 2 machines together, or even 3, because I have 2 ports here. But then the Sparks came out, and on the Serve the Home channel, I saw this MikroTik switch that just recently came out. Not sponsored by MikroTik. I bought this thing. That router is a little bit more expensive. Not only is the switch $1,200, which is actually not bad considering you get 2 400 gigabit ports, 2 more 200 gigabit ports, 8 50 gigabit ports. So I got plenty of networking going on here. But also the expensive part is the breakout cables, some of which cost as much as a mini PC. You can also use optical cables, but those are even crazier pricing. And I saw this post on Framework's website by Forrest Johnson, who shows the kind of network setup. It's a hub and spoke setup here. There's also ring setup and a full mesh network setup. And he suggested for the PCI slots that are on the Framework boards to get an Intel E10 network adapter for each one of these nodes. Those are capable of 100 gigabit, and theoretically that would do the upgrade, but I had some limits because each one of these is pretty pricey and I needed 4 of them. I wanted to find some middle ground where I can prove that upgrading the network actually works or not. I was open to that possibility, but I didn't want to spend that kind of money. Plus the network switch I'm gonna definitely use on a lot of different projects, including clustering the Sparks, so keep an eye out for that video. So instead of going crazy like that, I went for this card, also available on eBay. A little bit more pricey, but not crazy, $24. This is the Mellanox Connect X4, and it's capable of 50 gigabit speeds. Same idea here, same size. Needed a riser cable. Worked fine on my desk, but then I realized when I needed to put it in a rack, I needed something a little bit more neat. So I got these little things shipped to me, also on eBay, and it worked. Now I ran a bunch of tests clustering these things together, and eventually I ran into an issue where Kimmy wasn't running. So I asked Donato to log in remotely and do his magic on these things. And he actually not only did that, he created this amazing script that you just kick off. You select which model you want to run. Now he's doing Llama CPP, so it needs to be a GGUF model because those are the quantizations that are compatible with Llama CPP. So there's gmktec. I'm gonna cheat and load a much smaller model because time. gmktec takes probably a couple minutes to load. I know, not a big deal. But let's take a look at this Q4KM, which is a pretty popular quantization. You can select what mode you're running in. By the way, this will be available on his GitHub at some point, he said. You can select which toolbox. These are built on top of his toolboxes that he created, which make it super simple to run these. You don't have to build Llama CPP from scratch for different backends like Rockham or Vulkan. I've talked about all these in my videos previously. These are just different ways that you can run LLMs on AMD machines. And this is detecting that we have 3 active servers that are going to be the worker nodes to accomplish this task. And then you just say run distributed server. There is some configuration for passwordless SSH that you need to set up first. All the instructions will be in GitHub. And then it automatically starts everything. Freaking amazing. You can just use Llama CPP's UI now that is available. I actually made a video about this, comparing it to Llama recently. This is way better. Sorry, Llama. You know it's true. There's the model. Let's say hi to it. And now this is actually running on the whole cluster. Now, what about speeds? Well, for a small model like this, it's gonna run fine on one of these machines because each model is probably 4 gigabytes in size. We have 128 on each machine, so don't run it on a cluster. The cluster is for big models. If you run a small model on one machine, it's gonna be faster than the whole cluster because you still have that networking overhead, whether the network is slower or faster. But you can run larger models. Here's gmktec. Now this is a Q3KS quant, but you can say you ran a 1 trillion parameter model on this. There's a better way to use this cluster. I'll get into that in a moment. Peak throughput was 8.8 tokens per second, and it looks like we're getting that with a concurrency of 1, the most here, for max tokens 512, 256, 128, and for 1024 max tokens, we're getting 8.7 tokens per second for concurrency of up to 32, which means you're sending 32 requests or 1 request or 2 requests or 4 requests. I wrote the suite of sweeps. That sounds weird to say, but yeah, it does a sweep for different concurrency levels, starting with 1 up to 1024. So you're sending 1 request at a time, or you're sending 2 requests at a time, or 1,000 requests at a time. 1 request at a time would represent like oh, I'm just sitting here and I'm chatting with my robot. Fair. It's a use case, but if you're doing that, just run the thing on your MacBook, okay? Don't have a cluster set up. If you're running agents, or in the near future, orchestration of agents, all talking at the same time and doing multiple requests, or even when you're doing coding and you're using code completion as well as chatting at the same time with your LLM that's code specific, concurrency plays a big role. And I've made videos for that, showing that as well, setups for that for members of the channel. By the way, if you're not a member, you can join. If not, that's cool. Just subscribe to the channel. You get all these videos. Members get extra videos where I go into a little bit more detail. And members also get to use special emojis. Go ahead, members, put your emojis down in the comments. Thanks for being members. Appreciate y'all. Now, if we're still talking about Llama CPP, not yet VLLM, and concurrency, I did run recently this B-Link, which has the exact same chip, by the way. And from my previous test, this is the fastest so far out of all the Ryzen AI Max Plus 395 machines, but it's not fast enough to show this kind of a difference. So here is an example of why you wouldn't run a cluster. So this is the Qwen 34B Q8 Quant Int 8. By the way, I am going to show different quantization levels. So don't compare them to each other, just compare them within the chart. So this B-Link machine runs the Q8 at 128 tokens per second on a single. If you then run this on a cluster, you're getting 64.8 tokens per second. Yeah, don't do that. Now, to answer that burning question, whether the network cards actually make things faster if you add a faster network card, and the answer is yes, but not by much. Now, when Donato was pounding on these, he tested his cluster of 2 on a 10 gigabit connection against a cluster of 2 here on a 50 gigabit connection, and he didn't see much of a difference. So I wanted to push it a little bit further, and I connected it to this little 2.5 gig switch, and I ran the cluster through my 10 gigabit ports on the Framework desktops. But since this switch is 2.5 gigabit, it went all the way down to 2.5 gigabit for the connection, just to kind of exaggerate the difference as much as I could. Now, I thought this was a 1 gigabit switch. It would have probably made more of a difference, but it's actually 2.5. So I mislabeled this, but I'll fix that. But you can see in the chart here, there is, in fact, a difference. So imagine buying that Intel A10 card. Yeah, that's probably going to increase this even more. But the difference between running a 2.5 cluster for this model, which is the Qwen 34B Q4KM, Llama CPP again, we're getting 51.9 tokens per second, and we're getting 67.7 tokens per second running through the faster interface. So turns out Forrest Johnson was right, along with a bunch of other people and the folks that sent me messages. Now again, if you're going to be running small models that fit only on one machine, run it on one machine. If you're going to be running really huge models like Kimi K2, you're getting 8 or 9 tokens per second across the cluster. Whether it's worth it for you or not, I don't know. Maybe it is, maybe it's not, depending on what you're doing. If you're going to be just having an agent go to work and you can wait for a week or so, let it do its thing. But most likely, if you want big models, you're going to be running in on bigger clusters, like that gigantic Mac Studio cluster that I recently showed on the channel, or even a cluster of RTX Pro 6000s, which are going to be insane. But as I mentioned before, there is another use for this, and I think probably a more useful use. It's a weird thing to say, but it actually goes back to this cursor post. They're running it against Opus 4.5 and GPT 5.2, but the idea is the same. You got an orchestrated set of agents that pound at your code base, at your large code base. There's some that are going to be doing some planning. There's others that are going to be doing implementation, but they're all doing little tasks. So if you're doing this locally, you would run either different models on each machine or the same model, and each one of these can handle up to very large models. 70 billion parameters would run easily on each one of these. So you can have 4 70 billion parameter models running, but the agent orchestrator shouldn't know which machine it's talking to. VLLM is well known for having really good concurrency support. You can see that here, obviously. Here I ran Qwen 34B, the 8-bit variety on Llama CPP, 51.8 tokens per second, versus VLLM, 1,371 tokens per second. Of course, that's not at concurrency 1, where VLLM does actually a little bit worse than Llama CPP. But to really take advantage of VLLM, you need to send it at least, looks like from this chart, 16 or 64 even in the case of 128 max tokens, 64 concurrent requests, which you can easily get if you have a set of agents that are working on your behalf. When you have max tokens of 1024, you don't need that many concurrent connections to really take advantage of that speed. So I went to town trying to get VLLM working across the set of clusters, but there's currently a bug that you can't do tensor parallelism across a set of AMD machines. You can do it with NVIDIA boxes, but there's a bug right now in VLLM repository. It's open source, by the way, and hopefully that bug will get resolved soon. However, you can still run VLLM and take advantage of the speed by running an instance of VLLM on each one of these. And each one of them can handle multiple concurrent connections at the same time. You just need to round robin between the machines as the requests come in. So I've set up a bunch of backends for each one of these nodes, set up the load balancer, and the load balancer exposes one IP address that I can query. That's the job of a load balancer. So my agent will now talk to one IP address. The load balancer will decide which machine this will go to because they're all running the same agents. If I had different models I was running, I would set up a load balancer for each one of the different models. And when I did all that, the throughput went to 687 tokens per second. And this is not a quant. This is the full-size BF16 of Qwen 3 4B, the original, in other words. But as far as Johnson said, this was only the hub and spoke configuration. There's also the ring network topology and the full mesh topology. So there's more things to be done here. But for now, I am pretty happy to see that we did get improvements this way, and I'm happy to share the other way of working with a cluster like this as well. For that full cluster breakdown video on how I set that up along with modified cooling, check out this video right here. Thanks for watching, and I'll see you next time.